Okay, here we're going to graph a more complicated example. Y equals 3 cosecant 2x minus pi over 2. Now for this we know cosecant is 1 over sine. So what I'm going to do is graph that as a guide. And wherever sine is 0, you get that vertical asymptote, right? So that's how we're going to graph this more complicated cosecant function. So we'll choose 3 sine 2x minus pi over 2 as a guide. All right, so just by looking at this, I can see the amplitude here is 3. The period is 2 pi over omega, so 2 pi over 2, so the period here is pi. The phase shift is phi over omega, so I see that this has a shift to the right, so the phi is pi over 2, and the omega is 2, and so the phase shift is pi over 4. Right, so that's going to be my starting point. And then my end is going to be the phase shift, which is pi over 4 plus the period. Right, so my ending point here is going to be 5 pi over 4. And this is a good review for graphing in general. All right, so I'm starting at pi over 4, and I got to end at 5 pi over 4. So to graph this guide, I'm going to choose a scale where each tick mark is going to represent pi over 4 radians. All right, so I'm ready to start. Let's do it. Be a little careful here. We are graphing cosecant, so that is 1 over sine. So what I'll do is graph sine dotted here. Let's get a good scale. So I need 5 tick marks, right? 5 pi over 4. 1, 2, 3, 4, 5, right? 1 pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. And then 5 pi over 4. So that's a pretty good scale. I will have to reduce that. Let's get a good amplitude. So we have to go up to 3 and down to -3, right? Our amplitude is 3. Before I continue, let me go ahead and reduce. 2 pi over 4 is the same as pi over 2. And 4 pi over 4 right there is the same as pi. All right, so I reduced and I have a beautiful radian scale there. Nice and easy, counted it out. All right, so we're graphing cosecant. I'm going to use sine as a guide. We know sine starts at 0, and we're starting here at pi over 4. It ends at 0, and halfway in between we get a root. It goes up to its max there, and its min here. And again, I'm going to draw this in dotted, because I'm just using this as a guide. All right, so there's one period for sine 2x minus pi over 2. So I just graphed the same thing. Now, I know cosecant is 1 over sine, so wherever sine is 0, I'm going to get a vertical asymptote for that cosecant graph, right? So I have a 0 here at pi over 4, another root here at 3 pi over 4, and another one here at 5 pi over 4. All right. Then I'll draw in that reciprocal relationship. All right, so for this cosecant, it's going to go up like that, asymptotic to these asymptotes, and at the min here, it's going to share that point and go down like that. All right, so that's one period for 3 cosecant 2x minus pi over 2. Now, erasing the guide is optional, but of course, that is not part of the graph. Picture looks something like that. All right, let's go to Desmos and see what it looks like. Okay, so I typed it in, 3 cosecant 2x minus pi over 2, and you can see this is the graph. If I zoom out, it goes on forever in either direction. The first asymptote that we drew was here at pi over 4, and so if I graph sine, you can see that's where the 0 was, right? And at 3 pi over 4, we had another asymptote, and then at 5 pi over 4, we had another asymptote. So we actually, on our paper, only graphed these two pieces. Of course, this continues in either direction forever. All right. Okay, so here we have another example here, a little more complicated example. We have -2 secant 2x minus pi. So for this one, we know secant is 1 over cosine. So as a guide, we're going to choose -2 cosine 2x minus pi. So wherever this has a 0, right, we're going to get those vertical asymptotes. And we know how to graph this. We have to be a little careful with this one. The negative in front means it has a reflection. So the amplitude here is 2, and I'll say with a reflection. Remind myself that I will have to reflect that. Now remember, the amplitude is the absolute value of A. So the amplitude is actually 2 here. The period is 2 pi over omega. So omega here is 2, so the period on this one is pi. The phase shift is phi over omega, so this is a minus pi, so that's a shift to the right. We have pi over 2, right? Pi over 2 is our phase shift. And we're going to consider that as our starting point. To get our end point, we take our phase shift plus the period, right? The phase shift plus the period in this case adds up to 3 pi over 2. So we're going to start our graph, one cycle of our graph at pi over 2, and we're going to end at 3 pi over 2. We'll go by pi over 2, but I think we need to go by pi over 4. We'll go by pi over 2 at first, and then we'll adjust. All right, so here's the scale. I'm going to take each tick mark by pi over 2, and I'll make sure they're kind of big here. So I need 3 tick marks. 1, 2, 3, right? So 1 pi over 2, 2 pi over 2, 3 pi over 2. Right? 2 pi over 2 is just pi, it reduces. And yeah, that's not going to be enough. We're going to have to probably go by pi over 4. Let's get our amplitude of 2. Okay, and the thing is, that's only 3 tick marks, right? We need 5 points. 5 points to determine our graph here. So I'm going to go actually by pi over 4. So I'm going to cut these guys in half. And I'll say this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. That's going to be a better scale. All right. Okay, so we're graphing -2 cosine. Now remember, usually we're starting at pi over 2. Usually cosine starts at its max, but it has a reflection. So it's going to start at its min, it's going to end at its min, and then it'll have its max in the middle, right? And then here's your 0. So this is a reflected cosine graph right here. Right? See how it's like upside down? Usually cosine starts high and it goes low, right? So that's reflected about the x-axis. And I did draw it in dotted because that is not part of the graph. I am using that as a guide to graph secant. Okay, so wherever this cosine graph is 0, I'm going to get a vertical asymptote for the secant. So one there at 3 pi over 4 and one here at 5 pi over 4. All right? And then I'll draw in that reciprocal relationship where they share the peak there, and then draw in the graph asymptotic to the asymptotes. And I got kind of a half there, a half piece there, and a half piece there. So there is one period for this particular secant. Looks a little funny because these got cut in half, right? But that's okay, that's how it works out. Let's go look at that one in Desmos as well. Oh, before I do that, let me go ahead and let me erase the guide because, again, that's not part of the graph. Erasing it's optional, but I think it looks better when I erase it. And so there's the actual picture for one period of secant. Let's go look at it on Desmos. Okay, so I typed it in here, -2 secant 2x minus pi, and this is what it looks like. Right? It goes on forever both directions. But when you can really see it when you graph also -2 cosine 2x minus pi on the same graph. Now we did start this graph at pi over 2, so you could see this upside down cosine graph right here. That was our guide. And then so the asymptotes were at 3 pi over 4 and 5 pi over 4 are the ones that we drew. There's also another one here at pi over 4. We could have put in another period and got that one as well, but that's the graph. Looks good. We got it.